Now student, we are going to solve this question number 7.26. Clear? In this question it is given to you, do the same exercise as above with the replacement of the earlier transformer by 40,000 and 220 volt. Okay, step down transformer. Now concentrate. Let's suppose if we consider situation of a previous question. Actually we need output power, this is 400 kilowatt, clear, and it should be available at 220 volt. Clear to you? But there is one change is to be taking place. Yes, definitely this line is having again resistance, and resistance value is given to you 0.5 ohm per meter. Clear? This distance is given 15 kilometer. Clear? And this side we have this power plant, or we can say this is generating power at 440 volt. Clear? So now only one change is to be taking place in this question. Instead of 4000 volt, now we are saying this is 40,000 volt. Clear? Now we have to find which one is good. Is high voltage transmission is preferred. Why? Clear? So now let us try to understand. First of all, can we find total current this is flowing? Yes, we can write like this, IIRMS. It is given by, we can say power output we have 800 multiplied 10 to the power 3. And what about potential? Potential is given 40,000. So I can say this is 40,000. 1, 2, 3. 1, 2 and we can say 3. So this one is 3. So this is 100 and this one is cancelled out. Clear? So we can say IRMS we are getting this is 20 ampere. Clear? Because we have potential difference 40,000 volt, we are getting only current this is 20 ampere. Clear? What about resistance of this wire? We can say what is the resistance between these two locations. Clear? So resistance offered it is given by, and we can say 0.5 ohm per meter multiplied with total distance. Total distance we can say 15 and 15 total 30. So again you are getting this value 15 ohm. Clear to everyone? This is 15 ohm. So we can say this is value of R we have. Okay, fine. So this is value of R, and now we have to find this is IRMS and we are getting R. So can we find power loss in this transmission? Yes, we can say this is given by IRMS square multiplied with R. Clear? What is value of IRMS? IRMS is given to you 20. So we can say this is 20 square multiplied with R. Clear? Value of R we have this is 15 ohm. So we can say this is equal to 400. Clear? 400 multiply 15. So we can say 60, and we can say this is 6000 watt. Clear? Or you can say this is equal to 6 kilowatt. Clear? It means if we are sending this power, or we can say this current at 40,000 volt, at the time there is only loss of 4 kilowatt is to be taking place in this transmission. Clear? So it means I can say what is the power, total power it is to be given at this level. Clear? So I can say if you are talking about total power, clear? So power it is given by 800 kilowatt that we have to supply to small town, and 6 kilowatt power we are getting. So this is 806 kilowatt. Clear to you? Now let's suppose if you want to know, let's suppose definitely for that one we are using step up transformer. So what is rating of that step up transformer? So we can say how can we calculate here total potential drop? Yes, we can write like this. Potential drop is given by IRMS multiplied with R. Clear? IRMS we have this is 20 ampere, and what about resistance? Resistance is given to you 15 ohm. So we can say this is 15. So we are getting this is 300 volt. Clear? So now we can say 40,000 volt we are getting at this coil. Clear? At this end. So definitely if we talking about this transformer, it should have 40,000 plus 300 volt, because 300 volt potential drop we are actually losing due to this resistance. Clear? So now I can say what is the rating of step up transformer. Clear? For step up transformer we are getting this rating, this is equal to I can say 440 volt, and from there 4300 volt. Yes or no? Clear to everyone? Yes. So can we find what is the total percentage loss? Clear? So I can say if I find percentage loss in first situation or in the previous question, clear? You can say at the time you are saying 600 kilowatt is lost and 100 kilowatt you are giving you are taken from this power plant, clear? So from here you can say this one is cancelled out and this is equal to 600 divided by 14, and we can see if you multiply, if you divide it, you can see near about 43% loss you are getting, clear to you? But what will happen whenever we are talking about percentage loss in this question, in this particular question, you can say only 6 kilowatt power we are losing and we are giving input as 608 kilowatt power multiplied with 100, clear? So now we can write like this, this should be equal to 600 divided by 806, clear? We are saying this is 806 and we can see this should be equal to, now 600 divided by 806 means this is less than 1, yes or no? It means we are getting this percentage 0.74%. Now you can compare in this question. In this particular question, you are saying that only 0.74% of the total power given is going to the waste, clear? It is result in a wastage, clear? But in the first situation, 43% of the power is wasted. It means now we can say yes, it is always be better if we are giving power at a higher voltage. So higher voltage transmission is always preferred if we want to reduce the power loss, clear? So this is all about this question. So dear student, this is all about NCERT discussion, class 12th, chapter number 7, alternating current, clear? So hope you enjoyed this session and definitely these solutions will be very useful to you, as well as you will find the exact video solution of each and every question, clear? And definitely you will be benefited in your upcoming examination, clear? So revise all these questions again and again and good luck for your examinations. Thank you so much.